Okay guys, so on this video we are going to review some stuff that we already know about trigonometry, but we're going to talk about trigonometry identities. And in order to do so, let's review some stuff that we know. Cosine of theta, I always say that that represents an x-coordinate somewhere on the unit circle. So cosine's associated with x, and that means that y is associated with a y-coordinate somewhere on the unit circle at that particular angle. And we know that tangent, it's the same as sine of theta over cosine of theta, which ultimately means it's just the y-coordinate over the x-coordinate. So let's first talk about this word identity in math class. Obviously you've come across the word identity before, but basically an identity, it's a mathematical statement that is always true. And what our goal on this video is to discover and apply a particular identity called the Pythagorean identity. And it's actually going to be related to the Pythagorean theorem, which you hopefully remember from geometry. We'll make Mr. Tancreder and Mr. O'Farrell proud here. The Pythagorean theorem, it only works for right triangles, but you take one side, square it, you take the other side, square it, so we're calling those two side lengths A and B, and those together equal the hypotenuse squared. So hopefully this isn't the first time that you're ever seeing the Pythagorean theorem. Now I have a little picture here, and we've got a unit circle, and I know that it's a unit circle because the radius is 1, and I can see that right on this hypotenuse here of this right triangle that's in the circle. So we have this right triangle in the circle, hypotenuse is 1, so think of that C value as being 1, and it intersects the unit circle at a point. Now that point has an x-coordinate and a y-coordinate, but we know from earlier in the chapter we could represent that x-coordinate as cosine theta and represent the y-coordinate as sine theta. So if you think about this right triangle here, I could say this side, which we're calling x, this basically gives you the x-coordinate, this side length right here. That side squared plus the other side squared, which is equal to the y-coordinate. That's got to equal the hypotenuse squared. However, the hypotenuse in this case is 1, and 1 squared is 1. Okay, so that's not too crazy, but let's bring in some trig. X is the same as cosine of theta, so I can replace that x with a cosine of theta. And I'm squaring the whole thing. I'm not squaring the angle, I'm squaring the whole value of cosine. And y is being squared. That's sine of theta, so I'm going to square all of sine, not just the theta, it's the whole value of sine, and that equals 1. Now, oftentimes when we have a trig value like this being squared, for whatever reason, they always sort of move that exponent more towards the s part of the cosine. It's just a notation thing. And the same thing with sine. And actually what we just wrote, this thing right here, is the Pythagorean identity. It is based on the Pythagorean theorem. We know that this side length here is cosine theta, this sine is sine theta, and based on what the Pythagorean theorem says, this side squared plus this side squared equals this side squared. Now you might be thinking, this doesn't seem like that big of a deal, but it's going to let you answer a question that looks like this. Suppose that cosine of some angle theta equals 3/5. I don't know what theta is. but I do know cosine of theta is 3/5. I've got to somehow use that fact to find sine of theta. So if I think about what the Pythagorean identity says, cosine squared theta plus sine squared theta equals 1. Let's fill in what we know. We know that cosine is 3/5, so I'm going to plug it in and square it. And the first thing that I need to do is get sine squared of theta by itself. So 3/5 squared is 9/25. I'm going to subtract that to the other side. And that is going to leave me with 1 minus 9/25, which is 16/25. Now, the problem is sine is being squared. So, if we square root this side and we square root the other side, not forgetting our plus or minus, sine of theta ends up being plus or minus 4/5. Now, we're not given any information about the quadrant that this angle is in. Cosine's positive, which means it could be in quadrant 1, making sine positive. But if cosine's positive, that angle theta could also be in quadrant 4, which would make sine negative. So we're going to keep the plus and minus. It could be either of those. We don't really have enough information to make a decision. But there you go. All right, we're going to look at this identity along with some other identities tomorrow. Make sure you bring any questions that you might have.